Welcome to Bethlahem Institute of Engineering. Bethlahem Institute of Engineering is affiliated to Anna University, Chennai and approved by AICTE, New Delhi. This institution was established in the year 2008.
Good morning. The topic is adiabatic lapse rate. In adiabatic lapse rate, the term adiabatic means heat that does not enter or leave the system. Any temperature changes will take place internally. For example, if we are taking a flask and pouring some hot water means the heatness of the water will sustain throughout the day. This is because the heat which is inside the flask will not come outside and the heat outside the flask will not enter inside. This is known as adiabatic process. Lapse rate means a rate of fall in temperature of atmosphere with elevation. When we go upwards towards the atmosphere, there will be a change in temperature that is known as lapse rate. Adiabatic lapse rate is the rate of fall in temperature of a rising or a falling air parcel adiabatically. Adiabatic lapse rate is governed by gas law. Gas law means pressure is directly proportional to temperature when volume is constant. This same concept is applied in adiabatic lapse rate. So only we are saying that this adiabatic lapse rate is governed by gas law. In this, when we go upwards in the atmosphere, the pressure decreases. Due to the low pressure, the air parcel expands. Due to the expansion of the air parcel, the temperature decreases. As a result, the air will get cooler. And when we come downwards in the atmosphere, the pressure increases. Due to the higher air pressure, the air parcel will get compressed. Due to this compression, the temperature will increase. As a result, the air will get warmer. So from this we can understand that when pressure increases, temperature is also increasing. And when pressure is decreasing, temperature is also decreasing. So finally we can say that pressure is directly proportional to temperature. So the same concept is applied in this gas law. Pressure is directly proportional to temperature. So only we are saying that adiabatic lapse rate is governed by gas law. Condensation of water vapor, thunderstorms, cyclonic and anticyclonic conditions depend on adiabatic lapse rate. Then latent heat of condensation. It is the heat released or absorbed during phase change. During phase change, the heat supplied is consumed to turn solid into liquid and then liquid into gas. Hence, temperature of the system remains constant during phase change process. But when gas turns into liquid or liquid into solid, heat is released. So here in this diagram we can see that in order to turn the solid into liquid state, at this point the temperature at the starting point the temperature is increased, and in this point the temperature remains constant as solid is turning into liquid. This point only the solid is changing into liquid, which means the system consumes the heat to change the solid into liquid. So this point is known as latent heat of fusion. Then in order to change liquid into gaseous state, the temperature is again increasing and at this point the temperature remains constant as liquid is turning into gas. At this point only the liquid is turning into gaseous state. The system consumes the heat to change the liquid into gaseous state. And when this gaseous state is changing into liquid and liquid is changing into solid, at this time instead of consuming the heat, the system will release the heat. So this heat is known as latent heat of condensation. Environmental lapse rate, the rate at which the air temperature changes with height in the atmosphere. The overall average rate is a decrease of about 6.5 degrees Celsius per kilometer. Already we saw that if we are going upwards in the atmosphere, there is a change in temperature, that is known as lapse rate. So in environmental lapse rate, the change is for each kilometer there is a decrease of about 6.5 degrees Celsius. This environmental lapse rate is also known as normal lapse rate. Then types of adiabatic lapse rate. There are two types of adiabatic lapse rate. One is dry adiabatic lapse rate and the other is wet adiabatic lapse rate. First one is dry adiabatic lapse rate. It is the rate of fall in temperature with altitude for a parcel of dry or unsaturated air rising under adiabatic conditions. The dry adiabatic lapse rate equals 10 degrees Celsius per kilometer. So this dry adiabatic lapse rate is greater than normal adiabatic lapse rate. In normal adiabatic lapse rate we saw that it is a decrease of 6.5 degrees Celsius. Here it is 10 degrees Celsius. So it is greater than, so this dry adiabatic lapse rate is greater than normal adiabatic lapse rate. This is because in dry adiabatic lapse rate the air contains only less moisture. It is mainly associated with stable conditions. So stable conditions means there won't be any rain or thunderstorms. The climate will be in a pleasant condition. Then wet adiabatic lapse rate, the rate at which adiabatic cooling occurs with increasing altitude. The wet adiabatic lapse rate equals 4 degrees Celsius per kilometer. So it is less than normal lapse rate. The normal lapse rate is 6.5 degrees Celsius. Here the wet adiabatic lapse rate is 4 degrees Celsius. So it is less than the normal lapse rate. This is because in wet adiabatic lapse rate the air contains high moisture. The moisture level of the air will be high. It is mainly associated with unstable conditions. Unstable conditions means there occur rain and thunderstorms. So in this diagram we can see that this is dry adiabatic lapse rate. So as dry adiabatic lapse rate contains less moisture, it is greater than normal lapse rate. This is wet adiabatic lapse rate. As this wet adiabatic lapse rate contains high moisture, it is less than the normal lapse rate. This middle line is known as condensation level. So in this condensation level only the cloud, then condensation of water vapor will form. Then weather conditions at different adiabatic lapse rates. So the different adiabatic lapse rates are absolute stability, conditional stability and absolute instability. So the first one is absolute stability. In absolute stability, ALR is greater than DALR. Here ALR means adiabatic lapse rate, DALR means dry adiabatic lapse rate. Here this dry adiabatic lapse rate is greater than adiabatic lapse rate. So as this dry adiabatic lapse rate is greater, there will be little moisture in the air parcel. Due to this, it won't rain. Next one is conditional stability. In conditional stability, WALR is less than ALR and ALR is less than DALR. WALR means wet adiabatic lapse rate, ALR means adiabatic lapse rate, and DALR means dry adiabatic lapse rate. In conditional stability, this adiabatic lapse rate is in between wet adiabatic lapse rate and dry adiabatic lapse rate. From this we can say that wet adiabatic lapse rate is less than adiabatic lapse rate and dry adiabatic lapse rate is greater than adiabatic lapse rate. So finally we can say this, here normal moisture conditions occur so that it may or may not rain. And the last one is absolute instability. Here ALR is less than WALR. ALR means absolute lapse rate and WALR means wet adiabatic lapse rate. Here wet adiabatic lapse rate is greater so that the air parcel contains excess moisture. More moisture will be in the air parcel. So due to that, rain and thunderstorms will occur. So this is all about adiabatic lapse rate. Thank you.